Two Russian-born scientists shared this year's Nobel Prize in Physics for experiments with a substance they discovered in 2004 called graphene, the thinnest and strongest material on Earth. A layer of graphene is a single atom thick, so tiny it would take more than 1 million sheets stacked on top of each other to reach a single millimeter tall. But if you stretched a sheet of the carbon-based chicken wire-shaped material over a coffee cup, it would be strong enough to support the weight of a car.
Despite being the lightest known material, it's also the strongest, harder than diamond, and 200 times stronger than steel. It can bend, is almost entirely transparent, conducts electricity and heat better than any other material, and allows nothing to pass through it except water. So how can the unique qualities of graphene help the world we live in? Imagine flexible cell phones, a TV thin as wallpaper that you could roll up and take with you.
Manchester is the centre of a new revolution, another globally significant, game-changing black swan event, and it's called graphene. And it was isolated here in the physics department at the University of Manchester. It's so extraordinary that in 2010, the scientists who made it were awarded the Nobel Prize for Physics. Now, in a story of serendipity and free thinking that rivals any in scientific history, these geniuses did what no one had done before and isolated graphene, creating the first ever man-made material in 2 dimensions. Graphene has almost limitless potential. It's so light and so thin, but it's strong and it's dynamic. The visions, the predictions of sci-fi writers and tech gurus are finally within our grasp. It is a carbon sheet, 1 atom thick, but 200 times stronger than steel. It's the lightest, most conductive man-made material on Earth. It can be used for DNA sequencing at a nanoscopic level. It can be programmed to attach itself to specific cells, like cancer cells, which will revolutionize medicine. It's almost completely impermeable. It could be fundamental to the storage and transport of fuels of the future. It stretches, it twists, it rolls to create bendable devices, not just touchscreens, but